Okay, guys, the next topic is what we call it sinusoidal wave. Let's first define a sinusoidal wave. Like those waves whose shape varies like a sine wave or cosine wave are called sinusoidal wave. I think you people are well familiar about this kind of wave in your simple harmonic motion chapter, where we discuss sinusoidal wave in a detailed way. We can also define it is a mathematical curve. Mathematical curve that describe the smooth repetitive oscillation. Like the oscillation should be smooth and repetitive. How we can write it is, how we can diagrammatically represent this kind of wave. Suppose this is y-axis and this is x-axis. Now the wave whose behavior changes like this. These are called sinusoidal wave. Now this is a wave at time t is equal to 0. Now after some later time, like if this wave, which I represent in the negative y-axis like this, and this point reached to this point, so it behaves like this. Now here, this wave, which is moving in the forward direction with a constant velocity v. Then as we discussed in the case of like traveling wave, that if we have a wave pulse which is moving in the forward direction with velocity v, at time t is equal to 0, the wave, the pulse is here. After some time t, this pulse, which was initially here, now move to this point here. If this is the point P, then point P is now here. So here we can write this distance to be Vt. So here this is the distance which is equal to velocity times time. Now in the case of traveling wave, which we discussed, I already plot the figure here. Like we have a wave pulse which at time t is equal to 0, the wave pulse is somewhere here. Then the position of any particle of this wave, like this is a kind of what we call it the transverse wave. In transverse wave, the wave moving in the forward direction while the particle are moving in the y or minus y axis. Like the particle, if a wave is moving in this way with velocity v, then the particle oscillate either up or down. This kind of wave is called what we call a transverse wave. Now here this is the transverse wave, so the distance of the particle, like if I consider this is my particle, like its equilibrium distance was this one. Now the wave is traveling, so the particle is oscillating up and down. Here the position of the particle is this one, which at time t is equal to 0, y, which is a function of x over t, is equal to 0. In this case, we represent it by a general function f of x. Now here, I will replace this function by another function which is a into sine kx. This is the sinusoidal function, which is at time t is equal to 0, because time is equal to 0. We consider the time t is equal to 0. Now after some time, the pulse reached to this point, which is another point p prime, and the position of the particle after time t, which is y is a function of x over t. Here the time was 0 because the pulse was initially the point where the pulse started, the time was 0. But here the pulse moved from this position to this position, so it takes a time which I represent by t. So the y, which is a function of now position and time, which we wrote in the case of traveling wave by this f of x prime. So in case of sinusoidal wave, the distance or the displacement of the particle of the medium is represented again by this function y of x over t, which is equal to a into sine k x prime, where a is the amplitude, the maximum or the maximum distance or displacement from its mean position. What it means? Suppose we are discussing the wave in a string. If the string is initially in this position, so this particle is somewhere here. But if a wave is traveling through this string, the string shape is like this. So this particle is now moved to this point. So here the distance from this equilibrium position of the particle to this maximum position is called amplitude, which is represented by a. And here we introduce another factor, which is k. K is called wave number. What is a wave number? We can define the wave number like the number of complete oscillations which exist in 1 meter of length. In 1 meter of length is called a wave number. Suppose we have a 1 meter of length. Suppose this is the length, which is 1 meter. And this 1 meter, the number of complete oscillations. Like suppose we have, let's suppose this is one complete oscillation, this is another complete oscillation, this is third complete oscillation. So this is called a wave number. And this wave number is normally represented by k is equal to 2 pi over lambda, where lambda is the wavelength. So in terms of this wavelength, the above equation, if I call it equation number 1, equation number 1 will become, if I call it, this is equation number 1, This is equation number 2. Then equation 1 can be written as y, which is a function of both position and time, but the time is equal to 0, is a into sine. We have k, instead of k I will put now 2 pi over lambda x. Or in other word, equation 2, which is y is a function of position and time, which we wrote like this, a into sine k x prime. Now this can be written as a into sine, instead of k I will put 2 pi over lambda into x prime, y of x over t. Now x prime, which we discussed in the previous case of traveling wave, x prime was x minus vt. If wave move in positive x direction and its value x prime is equal to x plus vt if wave move in negative x direction. Just go back and repeat your previous topic of traveling wave. In traveling wave we discuss about it. So if I replace x prime by this vector, x prime by this vector, the wave is moving in the positive x direction, then the displacement of the particle of the medium, which is y is a function of both position and time, will become equal to a into sine 2 pi over lambda into x prime, which is x minus vt. So this is the general equation of sinusoidal wave. This is the general expression or general equation, I can say it a general equation of sinusoidal wave. In the next video we will discuss different properties of this equation. Thank you.